Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to do a practice problem on Hess's law. If you haven't watched the video on Hess's law, I go into great detail on how to do this. This video is just one extra problem to see if you have this mastered. So let me show you the prompt, okay? It's also written on the board, but it might be easier to see right here. You might want to pause the video and write this information down. Okay, so we have these three reactions that are in the prompt, okay, that I've written on the board from the prompt that I just had up on the screen, okay, and the question is asking, calculate the enthalpy change for this chemical reaction, knowing these chemical reactions and the enthalpy changes that are associated with these chemical reactions. So the first thing that we need to do is we need to analyze each of these equations and see how they relate to what the question's asking, okay? So when I analyze this first reaction over here, there's oxygen in it, but there's no oxygen in the original or in the question. There's carbon dioxide, not there. Water, not in there. Really, the only chemical that's in this equation is the C2H2, okay? So this is the item of interest for me in the first chemical reaction is the C2H2. And the C2H2 in this reaction is on the reactant side, but the C2H2 in the question is on the product side. So what that tells me is that I'm probably going to have to flip. I'm going to have to reverse this chemical reaction. And remember, when you reverse the chemical reaction, you have to switch the sign. So the magnitude is going to stay at 1300, but instead of a negative 1300, it's going to be a positive 1300. And I'll rewrite the equation over here in a second. But let's go ahead into reaction number 2 and analyze it. Okay. When I look here, the oxygen's irrelevant, the carbon dioxide's irrelevant, but the item that's interesting to me is the carbon, because carbon doesn't show up in any of these other reactions. And there is carbon in my original or my question, okay? But there's two carbons, okay? In this reaction, there's only one carbon. So when I analyze this reaction number 2, I think I'm going to have to multiply this one by 2. So I'm flipping the first one, and I'm multiplying by 2 for the second one, okay? And then when I analyze the third one, the hydrogen, oh, that's in there. What about the oxygen? Nope. What about water? Nope. So the item of interest here is going to be the hydrogen. Hydrogen's on the reactant side. Hydrogen's on the reactant side. I don't have to worry about flipping. There's one hydrogen here, okay? Or one H2, I should say, and one H2 here. So I don't think I have to do any multiplying. I just need to keep, this one. So I don't have to do anything to this. I'm just going to leave it the same. I'm going to keep it the same. So I'm going to go ahead and go over to the left side of the board. And for this first reaction, I'm going to flip it. For the second reaction, I'm going to multiply it by 2. And for the third reaction, I'm going to leave it the same. And then I'm going to add them together, and I'm going to hope that it works out to what the question, the prompt is asking. If not, then I might have to adjust these another way. So it's kind of like a little bit of trial and error, but this is the analysis that you do for each of the equations. And if you do really good analysis, 99% of the time, it's going to work out just perfectly. So let's go ahead and flip the first reaction. Okay, so the reactants are going to be products, and the products are going to be reactants. Okay, so when I flip it, I'm going to get 2 carbon dioxide, a water, and that's going to yield the C2H2. Okay, that's what puts it on the product side. Okay, as well as 5 halves O2. Now the delta H is no longer negative 1300. I flipped it, so the delta H is now positive 1300 kilojoules. Okay. For the second reaction, I'm going to multiply it by 2. So I'm going to put coefficients of 2 here, here, and here, and then I'm going to double the enthalpy change. Okay, so let's go ahead and multiply the second reaction by 2. So that's going to be 2 carbons, 2 O2s, and 2 CO2s. Now the delta H here is going to be 2 times the negative 394, and 2 times negative 394 is negative 788. negative 788 is the new number. Because I doubled the reaction, you double the enthalpy change because enthalpy is an extensive property. And then for reaction number 3, I'm leaving it the same. So I'm getting H2 plus 1/2 of O2. And that's going to yield an H2O. And because I didn't do anything to this reaction, the enthalpy change is going to be exactly the same. It was negative 286, and we're going to leave it at negative 286 kilojoules. Okay. Now we need to add the chemical reactions together. Okay. And when you add the chemical reactions together, you're going to put all of the reactants on the reactant side. So I got 1, 2, 3, 4, 5, 6 items here on the reactant side. Let's go ahead and do that. Let's go ahead and double check that. 2 CO2, an H2O, 2 C's, 2 O2s, an H2, and a half O2. And then I do the same thing on the product side. I'm going to put all these products on the right-hand side. 1, 2, 3, 4. 4 items, okay? Not the 6 items that I had on the other side, so this should be a little bit less, but still a lot of work. And double check my work here. C2H2, 5 halves O2, 2 CO2, and an H2O. And when we get to this point, we got to cross out like terms. So some of the things that are going to cross out are going to be the 2 CO2s on both sides. Those are going to cross out. The water is going to cross out on both sides. And then the 5 halves of O2. So remember, I got 5 halves of O2 right here, and I got 2 O2 here, which is like 4 halves, and the 1/2 here. So 4 halves plus 1/2 would be 5 halves. So those are going to cancel out. These two are going to cancel out the 5 halves over here, and we're left with 2C plus H2 yields C2H2, and that's it, okay? And that is what the prompt is asking for, 2C, an H2, and a C2H2. So if I've added these chemical reactions, then I need to add these enthalpy changes, okay? So remember, I flipped this from negative 1300 to positive 1300. I doubled this enthalpy, and I left this enthalpy the same. And when you add these 3 up together, the delta H is going to be a positive 226 kilojoules. So the answer here for the enthalpy change for this chemical reaction is an endothermic reaction because it's increasing its enthalpy by 226 kilojoules. So I was able to figure out this reaction with the given of all these 3 reactions over here. And that's how you kind of tackle Hess's law. If you found this content helpful, please give it a like and subscribe. And when you add that comment in the comment section, it really pushes this information out to other students that are interested in learning chemistry.